Today I will be introducing you to a new formula. Up till now you have heard or seen these type of terms in this chapter. First, choosing or selection. Second, arrangement. But today we will see a third term, which is distribution. So the first thing you have to learn is the formula which we will be learning today is applied when we have to distribute. So distribution of identical objects. Second thing is the objects must be identical. The question or the statement will be like this: identical objects and identical objects have to be distributed among R people. So in how many ways can we do this? Now suppose 10 identical chocolates have to be distributed among 3 children. So if X represents number of chocolates given to first child, Y and Z represents number of chocolates given to second and third child. Can we write this problem in the form of equation x plus y plus z equal to 10? Yes, we can. Now we have one equation and we have 3 unknowns. Therefore number of solutions are many, but the number of chocolates is a whole number, isn't it? It can't be in decimal. So the number of solutions of this equation is not infinite. It is some finite value. Because x, y and z can take only whole numbers. So now can you see that the number of solutions of this equation is exactly the number of ways in which 10 identical objects can be distributed among 3 people, isn't it? Because the same problem has been written in the form of an equation. Therefore the answer of these two problems will be the same. The first problem is, in how many ways can 10 identical chocolates can be distributed among 3 children, which is equivalent to the number of solutions of the equation x plus y plus z equal to 10, where x, y, z are whole numbers. Now x, y and z are whole numbers. This means that it is allowed that we can just not give a chocolate to one child. That is, it is possible that one or more than one child may not get any chocolate, because x and y or z can take value as 0. Okay, so up till now I haven't really disclosed the formula which is the answer. We are just trying to understand what are the points in which, what are the limitations in which we have to use that formula. The first is distribution, second is identical objects, third is whole number. X, y, z can take whole number. That means it is possible that some child, one or more than one child, may get 0 objects also. Now 3 key points we have understood. The fourth point is this: some people get doubt in this problem, that suppose 10 chocolates have to be distributed. I give one chocolate to one boy, second chocolate to second child, and one more chocolate to third child. So I gave them one chocolate each. So I distributed 3 chocolates out of 10, and 7 chocolates I have kept for myself. Is this a valid distribution? So please understand and remember that this kind of distribution is not legit. This is absolutely invalid. You have to distribute all the n objects. Okay? It may sound funny, but some people get this doubt. So once again, in how many ways can 10 chocolates be distributed among 3 children such that it is allowed that one or more than one children may get 0 chocolates? In how many ways can we do this? Or what are the number of solutions of the equation x plus y plus z equal to 10 if x, y, z belong to whole numbers? Now let us look at the answer, which is a formula you will have to memorize. So the formula is n plus r minus 1 c r minus 1, where n identical objects have to be distributed among r people, where 0 one or more than one people may get 0 also. So let us look at the first question, which is very simple. Direct, you have to put values. In the example we took, let us take it as the first question. So in that case, n will be equal to 10, r will be equal to 3. You will get the answer. Now let us go to the second question. Suppose x and y and z belong to natural number. That means at least one object has to be given. In that case, what will be the answer? So in that case, so you write the equation as if x, y, z belong to whole number. Then there is a condition that at least one object has to be given. So fulfill this requirement now. Give every child one chocolate. Okay. So every child has now one chocolate. Now we are left with 7. So now distribute these 7 chocolates among the 3 children. So we can reduce this equation, this condition of natural number to a whole number again by first fulfilling the criteria that at least one chocolate has to be given. Since we have already given one chocolate to each child, so now we are free of this limitation, but at the same time we are also left with only 7 chocolates. So these x, y, z equal to 10 can be converted into another equation which has variables a, b, c which belong to whole number category. So now use the formula for this equation. So answer will be 7 plus 3 minus 1 c 3 minus 1, that is 9c2. Now we will look at the third question. So can you pause the video and try to solve this third problem? So were you able to do it? It was a similar problem just like second question, isn't it? See, first of all we fulfill the criteria. We gave 3 balls to A, 2 balls to B and 1 ball to C. Now we are left with 15 minus 6, that is 9 balls. We have to now distribute these 9 balls among those 4 kids. But now we don't have any constraint. So that becomes exactly what our formula was made for, isn't it? So now apply the formula in the equation a plus b plus c plus d equal to 9. So the answer will be 9 plus 4 minus 1, C 4 minus 1, that is 12C3. So this is all for this video.